Okay, for section 6.1, we want to talk about modeling real life situations with a graph. So I have 7 problems on this screen that we're going to look at. And what we're going to do is we're going to match those to the graphs A through G. So if you look at example 1, it says a bowling ball rolls down the alley and drops into a trough behind the pins. And it even gives us a hint. It says which graph shows a horizontal line that suddenly drops. So that one, a horizontal line that suddenly drops, we only have one option right here, which is option D, but let's talk about what that means. So we have our bowling ball that's rolling at a constant speed. So we want to think about the speed and the time it takes for the bowling ball to get to the end of the alley. So our x-axis is going to be time, and then our y-axis is going to be speed. So if we think about it, as it's rolling down, the speed is constant. And then all of a sudden, the speed slows way, way, way down to a stop. Okay, so that's our first one. So now we can go ahead, graph D is used. So I'm going to go ahead and cover that one up so I don't even have to look at it. All right, so the next one that we're going to do is going to be a flower vase is filled with water. So thinking about time, over time, the water is going up, up, and up, and we're doing it at a constant rate. So that means that when the time starts, we have no water, and then it keeps going up, up, and up. So for this one, graph B is what's going to represent our situation. I'm going to cover that one up. That one's now been used. So part 3, a football is kicked and then caught by a person who runs down the football field with it. So this one's a little tricky. So we want to think about how far the football is going. We want to think about the time it takes for the football to get there. We want to think about the height of the football. All these things come into consideration. So I'm going to look at graph G. So the football's kicked. So the height of the football is increasing over time. So for this one, we're going to think about time and height. So the football starts and the height goes up, up, up. And then, of course, the football starts to fall down. And then the person catches it. And then that person's going to hold it at the same height and then run with it. So that's going to be graph G. All right. Now we have the cell of a widescreen television increases rapidly, peaks, and then levels off. So it increases rapidly. So we're looking at between E and F because graph A, that increases very, very slowly. So we're going to ignore graph A and graph C. So notice here in graph E how it increases, decreases, and then increases again. Well, this one just says it increases rapidly, peaks, and then levels off. So notice how in graph F, it starts to stay constant. That's what we're going to mean by it levels off. So graph F is going to go with number 4. Okay, ice cream sales were steady all day at the music festival. So they were steady. That right here looks like graph A. Okay, right? It looks pretty steady throughout the day. Maybe there was a little bit of a peak, but then it's went back down to a steady constant rate. So graph A is going to go with our ice cream sales. All right, a restaurant opens late in the morning, experiences a lunchtime rush, and then empties right before the dinner rush. So graph E. So the restaurant opens up, people come in, it peaks, and then people start to leave, go back to work, and the restaurant empties out. So it has this big dip. And then at dinner time, it increases back up, has a peak, and then people start to leave and go home. So that's going to give us graph E. And then the last one, oh no, I can't really see it. Okay, here we go. Oh, so it says the noise level of the traffic decreases after the evening rush hour. So, oops, I didn't cover this one up. So the only one that's left is graph C, but we want to think about it. The noise level is really high, and after rush hour, the noise level is just going to go down, down, down as there are less cars on the road. So C is going to be our last one.